Welcome everyone. My name is Vince Hammond. I'm your host for this session 2, which is another video in the series of customizing DraftSight. In this particular session, we're going to focus specifically on when you are migrating from another CAD system over to DraftSight, and not from a user's perspective, but from that of either a CAD manager or someone that has been used to customizing their work environment, their menus, and other things like that. So we will focus particularly on those differences or those little nuances that you might see when you're coming over to DraftSight and things to watch out for. So let's get started. The agenda that I have for this video is first we'll cover some system variables and some nuances around that. We'll talk a little bit more about shortcuts and aliases. We did cover that in the previous session. And then I want to cover the CUI and menu loading. When we look at the custom user interface, the CUI, there's a couple things that you need to be aware of. There's some limitations and also some opportunities. And so I do want to take a little bit of time to talk about that. The next thing we want to go over is around block management and dynamic blocks. DraftSight does support dynamic blocks, but there's some very unique things that happen with these dynamic blocks that I think are very important, especially if you need to do any type of automation, customization, or things downstream. You need to know what's going on with these dynamic blocks. So I'll cover that in a little bit of detail there. After that, we'll talk about a couple best practices when it comes to customization, and then I'll go into a couple Lisp functions and some commands. And then we will talk about a Lisp editor, and then also I will give you some advanced examples or some other examples of things that you can do with Lisp to hopefully get you thinking about opportunities that you might have as you come into DraftSight and start to really think about your environment, your tools, and things that you might want to take a look at making changes to or upgrading. So let's start with system variables. When I look at system variables, there's a number of variables in DraftSight that are different than they are in other CAD systems. For instance, one that I'm very familiar with, and you might be as well, is your OS mode, your object snap mode. Now in DraftSight, the command for that is called set snap mode or set SNP mode. And so what you'll notice is when you go to enter that command OS mode, right below it, and you'll see it on the command line, it will tell you what the translation for that actual command or that variable is, our system variable. In this case, it does present it as set snap mode, and it gives you the default value. We can also in Lisp set var OS mode, and that will work. But just to keep in mind that when these things happen, oftentimes these are translated. Another good example is face trees. This is one I change all the time to up my resolution, especially if I'm working on 3D objects. But you'll notice if I type in face trees, the actual command in DraftSight is, I'm assuming it's legacy face trees, so LGCY, but basically the same command. Why that's important is because oftentimes if you're bringing over custom routines or things and they don't work, it's a possibility. Now, I think 99% of those variables are already there in DraftSight, but there's a possibility that you might find a variable that is not there or it may not work. It's also good to know, what the original or the core command is inside of DraftSight. Now, I might recommend if you are still setting these variables, whether it's in a Lisp routine or if it's in a macro or a command, a custom command, that you still use the same legacy or what I'll call ACAD version of those if you need to take your programs and go back and forth between both systems. Now, if you're only, from this point forward, only going to be using this customization or these programs inside of DraftSight, then you might consider just using the native or core commands. But just keep in mind, if you use things like, and for instance, I'm looking here at get distance as a variable. If I use, if I'm grabbing this variable as get distance, a set var variable, and then I put it in a program and I try to use that program in some other program, it will not work because that command does not exist. So something to keep in mind when it comes to customization, especially in Lisp routines or things that you might have to run in multiple systems for the time being. So let's talk about those aliases a little bit more. If I look at the current alias list, you'll notice that there is no command for area. It's actually get area, and it's an alias that is giving us that get area command. So if I type area at the command line, I will get the actual core command get area. It shows me that, and then it runs the area command. Now, if I'm using a get var to get the system variable area, which is the last result that was run from the area command, and it's a real number that is the result of that, then you will see if I use get var area, then that still works, and that it's still a system variable in DraftSight, but the command is different. So just to be aware of it, it's one of those things where if you try to import a PGP file and you're trying to create a shortcut for the command area, that it actually has to do an alias of an alias. It will work, but it can be confusing, and in some cases, if that command doesn't exist, and I pointed this out in the last video, if that command technically doesn't exist, then the shortcut won't work either, especially if it's one of these core commands that's not the same as the other CAD systems. Now, my recommendation is if you really want to bring in PGP file, I would just segregate those things that are different, those things that are custom, those user specific things that you've done, and not the rest of the core commands. I think that, again, in this situation with DraftSight, 90%, maybe even more, of those shortcuts or those commands are already in DraftSight. So you probably only need to look at those things that are custom. Now, my recommendation, what I think is an even better situation or a better methodology, and I did show this in the last video as well, is to create a macro or a Lisp routine in your startup and then define those functions as your aliases. It gives you more flexibility, more ability to take that to another system, another computer, or to be able to update it or upgrade it later on rather than having to get in and import, export these the PGP file from other CAD systems, or in DraftSight it's going to be an XML file. But uh, honestly, I really think the startup is an easier way to do it, and it gives you, again, more flexibility. The example I showed last session was the fillet command. I think this is a great example. These are just simple defined functions, but I have the ability now to not just run the command, but run the command with options. In this case, I can put in the radius, and then I can specify that radius and then run the command. So it's basically one keystroke to do multiple things. Now, I will show you this a little bit later, but again, this goes in your startup and it's simply just a text file. And when we look at it in something like a Notepad++, you can see that there's definitely some things that make this file easier to read when we have the color coding, especially when commands and defined functions and numbers show up specific colors. These are my colors, but you can set that to anything you want in a product like Notepad++. Highly recommended. So let's talk about the CUI. There's some real interesting things that happen in this environment in AutoCAD in terms of the CUI. And what I want to point out is that the user profile doesn't contain everything. You can't just take one file from that environment and bring it into DraftSight or into another workstation for that matter and replicate the entire menuing system and custom user interface that you have. And what's a challenge with this is where we do our customization is typically around the partial CUI. It's hard to move things. You can't move things from a partial CUI to a main CUI. And also the CUI contains a workspace, but it doesn't contain the tool palettes. And the profile doesn't contain the workspace, but it does contain the main CUI. It gets to be really confusing. It can be a real challenge to synchronize these things. And I think the other thing that I want to point out here is that tool palettes, which tends to be the area that most people customize, especially CAD managers, are not part of the CUI system at all. It's a completely independent system. So what I look at is if I'm going to do any kind of migration, if you notice when you go into the CUI editor in DraftSight, you do have the option to import a CUI or CUIX file. You can also import an old legacy MNU file. That'll import as well. But again, similar to aliases, I might recommend that you look at these and determine if it'd be easier to create these commands, the command structure, and some of these things from scratch, versus importing them. Now you can, but it's just a word of caution that there are some limitations. Now, when I look at DraftSight, if you've built a bunch of tool palettes, you cannot import those tool palettes into DraftSight. It is a limitation, but then in some ways it might actually be a blessing in disguise. Tool palettes can be a little bit challenging to work with, but let's talk about an alternative. We have a design resource tab. It's over on the right side where your properties palette is, and you can go to the design resources and grab your blocks right from within a drawing, or grab a drawing that may be represented as a block and drag it and drop it right into your drawing. It's a very easy system to use, and what I would recommend is if you organize this properly, it'll be much easier in some cases to navigate and grab things from the design resources tab over into your drawing. Now, some people will take a drawing and they'll put all of their sub blocks by category into one drawing, and that's fine here because you'll notice in the design resources, if I pick on a drawing, I can pick out of it multiple blocks that might be within that drawing. So I can simply drag that block from this drawing that's highlighted into my current drawing. Also, I have access to sub objects. So maybe I have a standard file that has a bunch of layers, or I have some templates or sheets or layers, line types, some table styles, things I've developed that are in a template. I can grab those from the template and drag them out of the Design Resources tab into my current drawing. Very powerful. The one thing I would make sure you do, though, is if you're going to put a system like this together or using this, just be extremely thoughtful about how you're going to organize your blocks and your title blocks and things like that. It'll just make your life a lot easier to be able to navigate. And then also, as I've mentioned before, probably a good idea to put these things in a public folder somewhere you have access to. Just like the CUI or the aliases, by default, those things are stored off in a location that's under your app data, which is normally hidden. So I would highly recommend you look at remapping these blocks, drawings, these special drawings that you're going to use, your standards, and put them in a public folder, easy to get access to. All right, so why don't I jump over to DraftSight and show you some things about the design resource tab. Now, let's see, I think some of the stuff is going to be hidden. I'm going to drag this over so you can see it because I think my video is up here in the corner. So if we look at the resource tab, you'll notice that if I look at any of these folders, in fact, if I pick on this folder, you'll see all the drawings that are inside of that folder are represented and shown with a little icon. And I can simply take any of these, like this copier, I just drag it in here. I can place it. As for the scale and the angle, I could put in there, and there it is. Simply drag, drop in my drawing. There's a preview down here, but also if I pick on any drawings, you'll notice here it shows me the content of the drawing. Blocks, layers, line types, text styles, things like that. So I can grab any of those items from any other drawings that are inside of these folders. Now, there are some limitations, and that I wanted to bring up is that once you drag and drop, you can't really control within design resources what the behavior is. So for instance, whatever my current layer is, if I drag and drop that block into my drawing, it's going to go on the current layer. And also you notice that I could not control, I had to do the scale factors, I had to do the rotation. If there were attributes, I would have to answer those questions for the attributes that would be prompted for me at that time. So we cannot customize the behavior that happens within the palette system or the design resources system. So that is a limitation. But that being said, the other thing I would say that is a definite advantage is if you get a collection of blocks, maybe there's a whole new set of blocks that you're going to want to add to your system. If you just put them in the folder and you click on that folder within the browser, it'll automatically show you all of those block drawings. If you notice, I didn't have to do any customization to that tab or to that interface to make all those things show up. If I wanted to put all those into a palette system, I would have to define each one of those individually and set up the information for those. So I do think it's a better system. I think it's cleaner and it gives you more flexibility. You can organize with simply, Windows Explorer to reorganize your files, and it's really easy to use. So definitely something to look at. The other thing I wanted to point out is if you've done any customization to a tool palette system in the other CAD systems, you'll notice that it can be extremely tedious and cumbersome to manage. The tool palettes have each of the groups or each of the tabs that you create has its own unique name, but it throws an extremely large, long, random number name into each of those files, and each of those they're all saved as ATC files, and then all the images are all also very long. And the unfortunate part of this, and from a CAD manager standpoint, if I build a whole palette system, I have to go through all those one at a time to determine what those are. Even if I name them something very specific, the images and the commands and all those things that are captured have these random names. It's really can be very tedious and hard to manage. This is just something I thought I'd point out in case you haven't already experienced that yourself. All right, on to one of my favorite subjects, and that is blocks and block management. And then also dynamic blocks. I do want to really point out some things that go on with dynamic blocks because I think it's really important, especially if you're coming from a system that you've been able to author these. And you might think of this as a limitation, but I want to point some stuff out to you because I think it's really important you understand what's going on with these. As I've had to work with them many times with many companies, and so I think it's important that you understand some of the things that I've observed over the last few years. So let's talk about blocks. Now, one of the things with the standard block is if I go to insert a block and I put in the name in an insert command, DraftSight, just like any other CAD system, will look in the drawing first to see if the block exists. If it doesn't exist, it'll go through the support folder, see if it can find it as a drawing. If it can, it'll then bring it in. But by default, it naturally looks inside the drawing internally. Now, if I specify in DraftSight, when I hit, instead of just picking the name, if I specify using the browse and I pick on the file, I will get a prompt that says, do you want to overwrite this block? It will alert me to the fact that I'm overwriting and bringing an external file into my drawing, and I'm going to wind up overwriting the file. Now, what's important to know about this, in other CAD systems, there's something called expert mode, and if you set the expert mode to a value of 2, it does two things, multiple things. First, it overwrites if you ever get a prompt that says, hey, this drawing already exists, you want to overwrite it. And then it also suppresses that warning that says, hey, this block already exists, you want to overwrite it. However, in DraftSight, the expert mode, if you type in expert, the actual command that you're going to get, expert is an alias. So the command is set cmd prompt prmt level LVL. So that is the actual command. But different from other CAD systems, 0 is normal and 2 suppresses that warning about you're going to overwrite an existing drawing, but it does not suppress the block overwrite function. So very important to note, especially if you have Lisp routines that set the expert to 2 before it does something. Now, how do we get over this? Now, in DraftSight, just like other systems, if I want to force an overwrite, I can use the -insert block name equals file name in a Lisp routine or a script or whatever, and then I have to answer that question. So if you look at the screen here, you'll see when I put in insert block name and I use this path, it will come up and ask me if it exists in the drawing. Does it already exist? Do you want to overwrite it? Yes or no? Now, this presents a challenge because if the block doesn't exist and I try to do this, this won't work. But it'll only work if it does exist. And so if as you go through the lessons in Lisp, you'll find that this is an example that I use where you might create an if statement that checks the tables in the drawing to say, hey, before I try to insert this block in this routine that I'm going to do, because I want to overwrite it, I want to update it, I want to force an update because maybe I know that this is a newer version and I'm trying to update it in my drawing. If that's the case, then I probably want to create an if statement that says, if this block already exists in the drawing, then do it with this method. If it doesn't, just go ahead and insert it, and then we don't get that question. So just a sequence to point out, something to keep in mind when we're looking at blocks, and that you cannot suppress that that prompt that comes up. All right, let's talk about why we use blocks. Probably the number one advantage of using a block is just saving space, especially when we have extremely large drawings. Now, if I have, let's say, an object that is represented by 10 entities, or let's say it's an assembly, it's 10 lines representing that. If I need to replicate that 100 times in my drawing, well, if I simply copy those objects 100 times, I have 1,000 entities in my drawing. However, if I create a block out of those 10 entities and then I just insert that 100 times, I technically have, each insertion is only worth one entity. So I really only have 110 entities, the original block definition and those 100 insertions. So the difference is dramatic, especially when we start looking at drawings that have literally thousands and thousands of components. The savings and the speed and the efficiency of the drawing can be drastically affected by how we use or don't use blocks, especially when it comes into very, very busy drawings. Now, the other advantage to a block is, let's say, just like I talked in the last example, let's say I had to update or wanted to update the block version in the drawing. Simply by redefining that block, I can update every single insertion of that block at one time. So simple update, all the blocks will reflect that update across the board. Now, I can also attach attribute data to a block, or as you will see later in some of the other examples, I do teach you how to use Xdata as well. But let's say we want to attach some information to that block. Well, if I do it in the correct manner, I can automate either bill of materials, schedules, different data extractions. I can take all that information from those blocks that have been scattered around my drawing and extract that out and automatically put it into a bill of materials or a schedule and so on. So very powerful when it comes to data analysis, collecting data, collecting information about those blocks. Very, very powerful. Now let's talk about dynamic blocks. Now, the difference between a regular block and a dynamic block is, with a dynamic block, you can create custom parameters. You can do things very dynamically. So there's some very powerful things you can do with them. And you can also create what's called multiple visibility states. So I can control through a menu by picking on the block. There'll be these little tabs like the example you're seeing here. I can grab and I can say, show me a different visibility state. Show me something different about this block to represent it in a different way. So it gives you this dynamic control over what you can do with that block. Very powerful. However, there's some challenges. And so let me explain it this way. Let's say I need to use let's say I'm going to grab the entity data from an object. I'm going to use an entity select tool command. And this is all in Lisp, and you're going to learn how to do this. If you don't know how to do this already, you'll learn if you go through the course how to do this. But this is very simple. We're going to do an entity selection. We're going to take the first object from that list that's returned, and then we're going to do an entity get. And when we do that, we're going to get an association list. And there's two components in that list that are going to be probably the ones we want, probably the two most important. The first one is the association list for 0, which determines whether it's a block or not, or an insertion of a block technically. And the second one is going to be the name of the block. And so if I look at the data that comes from an ent get and I'm grabbing my object, you'll notice that there is a list, an association list 0 that shows me it's an insert, and the 2 shows me the name of the block that I've just inserted into the drawing, or the parent or the block that represents that insertion. That's the way a standard block would work. However, if I do the same thing with a dynamic block, once I've modified the dynamic block, the results are very different. So if you saw that example with a picture where if I just pull or change one thing inside that dynamic block and it's no longer the core base block, it's still considered an insert. It's still considered an insertion of the block. But what you'll notice, if you look closely, the association list for 2, which is the name of the block, has changed to now be *U3. What happens is anytime you make a modification to a dynamic block, the name of the block now becomes a random name, or it's basically it's numerical. It'll be star U and then a number. Why that's important is because now if I want to write a Lisp routine that says go into the drawing and grab all of the blocks that are schedule row and extract all the information from them, notice that this dynamic block is now named something completely different and I cannot grab it through that means. So I do want to show this, and maybe it's best if let's jump over to DraftSight, and I'm going to show you what I mean. So let's go into my block example. Here's that example, that drawing I was showing you before. This is a dynamic block, and if I'm in the drawing and I typed it before, so I should be able to see it. There it is, my int get. So I don't, just being lazy and arrow going up with the arrow key. If I select my block, pick on it, you'll notice down here, here's my schedule row. It's a schedule row block. Now, if let's zoom up on this. If I pick on it, some of the advantages of this block is I can change the height of it, which is really cool. It's a visibility feature, or I can change whether I can place a hatch symbol or something else in this area. But once I've done anything to change this, let's just change it to symbol. I hit escape. I've modified the block. If I go back to my ent selection, my ent get, and I grab it, you'll notice this is now changed to U6. So this block is no longer the same name as the other. Now this gets to be a little bit more. Let me show you a couple other things here. Let's go ahead and insert. And this is my schedule row. I'm just going to pop another one in here. Let's put it right here. And you'll notice that if I, again, look at this, this is going to be the original, where is it? There it is, schedule row. So that's the original. Let's say I needed to change this. Maybe I changed the table. Maybe I've redesigned these tables because we have a new standard in the company. I want to update all the tables. And so I'm going to use that method I told you before. If I go to insert, and instead of just inserting it, I'm going to go to browse, and I'm going to grab my newly defined schedule row block. It's been updated, and I say okay. It should give me that warning. Do you want to overwrite? And I say yes. You'll notice that I can place this block. Oops, and I missed my object snap. And you'll notice that this block actually changed. I don't know if it was very subtle, but I added a double line here. Let's just very subtle change. But you'll notice that the other block that's now the modified dynamic block did not change. Here's something else. Let's say I want to copy this block, and remember it was I think it was a U6, right? But let's take and just make a subtle change to this block here. And if I look at this one, what winds up happening is now this block is U7. So anytime I make a change, even if I change it back to what it was before, every time I touch it or change anything on this dynamic block, it now becomes another block. Well, why is that important? Well, let's take a look at this. If we remember the advantage of having space savings with blocks, if I copy that block and insert it multiple times, I'm only getting one object. But now that rule no longer applies. If I have a dynamic block, every time I modify it, it's a new name, even if I change it back to being similar to another block. So if I put 100 of these dynamic blocks in and I changed each one just a little bit or multiple times, it's possible I could actually wind up having more objects in the drawing than I did if I copied all those entities individually, because now every time it creates a new definition of the block, not only is it have an insertion, but it has those 10 entities again and again and again. So something to really keep in mind is that oftentimes I see drawings that have dynamic blocks, and they're actually larger than they would be if they didn't have blocks at all. So very, very interesting, but you have to understand what's really going on with these blocks to understand why that's happening. Now, something else that can actually be even more critical is you saw me change that block by redefining it. but you notice that only the non-modified dynamic block updated. Now, in a case for, what I was drawing, it's a schedule, probably not a big deal. But what if you changed something specific, like a part number or a part type or a piece of information that is critical to later on needing to extract that information to get the right thing? I'm using a schedule, but let's say, for instance, we use something that's more critical. Now we've updated some of the drawing, but not everything. Now, there are tools in these CAD systems to go ahead and update all these blocks, but the reason I'm showing you this is because sometimes the users aren't going to use those tools to make sure everything's correct. And so now you have a block of a drawing with some blocks being correct and other blocks possibly not being correct. It could cause a real problem. Also, there is limitations to doing process automation. As you saw, because now the block has a different name, I can't extract the data in an automated fashion in the same in a customized way that could be very, very efficient. So, give you an example, and I've seen cases where there have been CAD managers that have gone crazy with dynamic blocks, and then companies come to me later and say, "Hey, we want to extract all this information," and we find that it just becomes extremely difficult. So you'll see this later if you go through the training course. I do an example where I give you a title block and I can export the information through multiple different means just to get it out to an external file. Now, it takes about 4 or 5 lines of code in Lisp to make that happen. It's very simple, very easy process. I can grab all the entities in the drawing, check to see if it's a certain block. I can extract them either through an extraction table, the attribute extraction method, or I can use Lisp to do it to find different ways to do that. Now, if dynamic blocks are involved, the only way to do that through a highly sophisticated automated fashion is to write a specific program for every single block that you have that's in the drawing. And it is extremely tedious to try to dig multiple levels down to discover what is the actual name of the parent, because in a sense we have a parent block, and then all these other variations are all children. And so you have to go through the child to get to the parent, figure who the parent is, and then figure out how to extract that information. And in some cases, these children are orphans because if you change them and the parent changes in the drawing, then you've got, as you can kind of see by me explaining this, you can wind up with a mess. And oftentimes I have companies coming to me saying, "We've got a mess. How do we clean this up?" And the first thing I will say is we need to get rid of dynamic blocks where we don't need them or where someone kind of went crazy. A good example, I've seen this in civil engineering, where someone will put a symbol for a stop sign and a yield sign and a speed limit sign, and it'll all be the same block. It's just they'll change the visibility to turn it into a different symbol. Now, if you think about it from a user standpoint, I could easily make a menu that had a stop sign and a yield sign and a speed limit sign, and I could grab those and drag them in, and it would be very easy to place. But by having a dynamic block that has all that visibility, it actually is harder for the user to place it because they got to place the block and then they have to pick again to change the type of the block. So you're actually making more picks by creating a dynamic block that has all these different variations. And then if you wanted to add another sign, like a street sign or something else to that dynamic block, now all the ones that have been put in before you made that change are now, they're all orphan children, we'll call them, because they're no longer associated with the parent if you make any kind of an update. So just my take on dynamic blocks, as you can probably imagine, because of the thousands of lines of code I've had to write to manage these things, they're not my favorite. There are some cases where they're really cool and they can do some really creative things, especially with some parametrics. But honestly, if there's a way I can achieve the same thing with 3 or 4 blocks, instead of one crazy block, it's easy. Those 3 or 4 blocks are much, much easier to manage. Now, I know in DraftSight 2022, and at the time of this recording, it was not quite out yet. It was announced, and we did get to see some of the new features. There will be a feature to convert dynamic blocks into the custom blocks in DraftSight, and I'm very excited to test that because, as you can see, I probably want to validate what happens with these custom blocks and how they're managed and how they work. Now, there are certain cases where, like I said, they work really, really well. But if you're trying to do anything in terms of automation, you have to really consider, is the dynamic block or custom block the right way to go about doing that if I want to do data extraction? All right, so let's talk about some best practices. Based on this previous discussion, as you can imagine, block organization is going to be critical, something you really should look at in terms of, especially if you're migrating from another CAD system, you've probably got a golden opportunity to clean some things up, look at how you are organized, and maybe do some updates. And, again, with the dynamic blocks, are they really necessary? I use this example of the stop sign and the yield sign as being one block. Um, Chances are in that situation, you're probably never going to take a yield sign and turn it into a stop sign or vice versa. So having that ability to have it dynamic in that situation is probably not a really good use. And, think about it. Once I place that block, do I need to go back to it and constantly make changes to it? Well, then a dynamic block might be the right thing because I'm constantly having to move it, stretch it, do something with it. But if it's something that's very static, then it's probably better to have a very simplistic block and do that, especially when it comes to automation and data extraction. And we'll cover a couple of those examples at the tail end when we talk about advanced Lisp programming and some of the things that we can do there. I covered this before, looking at your aliases. I think it's still an opportunity to create some small Lisp routines that are going to be easier to manage. And then when you do a migration, if you're coming from another system, it's really a golden opportunity for you to look at, can we improve workflow? Can we update our standards? Can we clean up some of the documentation? Can we build better templates? There's a lot of things that can happen when you're migrating from one CAD system to another. It's always an opportunity to take a look at those things and see if you can improve. Finally, on this slide, I would say that it's really important to make sure you have a good system for being able to migrate or copy your standards from one computer to another. In the last couple of years, we've seen a lot of people having to work from home or else having to go back and forth, home to the office. And one of the challenges with that is being able to migrate or update your standards to have them synchronized or the same in multiple locations. And so it's very important that you put all your updates, all your customization, all those additional pieces that you put together, put them in a place that you can easily move from one to another. And I think putting them in the public folder like I've described here so far is probably a really good best practice in order to be able to be flexible in moving those standards around. Now, when it comes to setting up standards, I have a couple golden rules that I like to apply when it comes to the way you name your layers, blocks, drawings, Lisp routines, and things of that nature. In fact, I'm just going to build out this slide here. Some of the rules really have to do with the way you create these names or these standards so that you don't run into problems later on. For instance, I've had situations where companies have used really long descriptive folder names and file names, and then later on when it goes to being able to XREF, either binding or exploding or doing things with those drawings, they're not able to do that because of the fact that you can run into a situation where if a layer name gets to be too long, that process cannot be executed. Also, it becomes very difficult, especially when you're trying to troubleshoot or fix applications that are developed by somebody else. And I've seen this, where if the program name, the file name isn't the same as the program or the function name, it becomes very confusing and very hard to figure out where things are going wrong. So I really recommend a number of best practices here in terms of keeping your file name short, following certain industry standards if you have a standard for your industry. Also creating, if you can, create a translation type of a file or program to help with these situations. You may have a company standard that has been there forever, but you need to conform to another layering standard for giving drawings to other companies or bringing drawings in. Creating these templates or I'll call them conversion utilities, might be the best way to do it, but those things won't work well if you don't follow certain standards, like keeping the name short and or keeping, if you can, keep spaces out of file names and folder names, just because, the space is the same thing as hitting the enter key on the keyboard unless we execute those pieces of data in the right way. So just a couple of rules that I have when it comes to really building standards and or maintaining those standards. All right, so the next section we're going to cover is Lisp functions and commands. Basically, I'm going to go over some of the small nuances that you might find in DraftSight that are different than other CAD programs that you might be used to. Now, the very first one I'll bring up is the command called appload. Appload is not a command inside of DraftSight. The actual command is called load application. So if you're used to typing an appload or you have scripts that are typing appload to launch the interface, simply you just have to create an alias so that you have that command available. The next one is the methodology of getting the value of a variable at the command line. Now, I'm used to typing an exclamation point and typing the variable name to retrieve that value as I'm going through and testing. But in DraftSight, that function is currently not available. So an alternative to that is you might want to use open parenthesis, print, and then the name of the variable to retrieve its current value. Now, I'll give you an example of this. Let's say I set the variable x to an entity. Well, if I want to try to use that entity during a move command to see that I have the right entity selected, if I do exclamation X, it will not work. It'll tell me there's no function. And so the way you might want to do that is you can basically put the command within a command string, open parenthesis command move, and then X, there's your variable, and then the extra return there, and then that'll work. So just so you can see that I can use X as that variable that was set within a command string, but I cannot use the exclamation point, or like I like to call it bang. I cannot bang that variable to get the value for it. Now, sometimes we need to create Lisp routines that have to function in multiple CAD programs. If you have that situation and you want to run a different sequence of events, if you're in DraftSight, then you can simply get var the product name and it will retrieve DraftSight. So I often use this in different CAD programs so that I can do the behavior a little different if it's required for me to execute that series of commands. Now, when we talk about functions that are supported, there are two core sets of Lisp functions that are available. There are the standard commands that we use, and then there's the VL functions or Visual Lisp functions. Now, the VL functions are mostly supported in DraftSight. For instance, if I say VL-file-delete and then the file name, that command will work. It is supported. Now, what isn't supported is the VL editor or Visual Lisp editor that we see in other programs. So we do not have an integrated development environment where we can test our code, check our variables, do those types of things. We just don't have that environment available in DraftSight. Now, if that's critical to you, you might find that you have to maintain a seat of that other software just for the visual editor environment, because in DraftSight we currently do not have a VL editor that's available. Now, myself personally, I really only use that environment for doing compiling when I have clients that need their software compiled for specific reasons. But the editor itself, I personally don't use it because I found that there's some quirky behaviors and things that happened in that environment that actually made it more difficult for me than the just using a standard Notepad editor or something like that to work with my code. Now, the other thing I wanted to point out is currently with DraftSight, we do not support FAS or VLX compiled Lisp code. So if you notice, if you go into load application, you can load up your Lisp files, your LSP files, but you cannot load up or run anything that's been compiled via that VLite editor. All right, so talking about Notepad++, let's talk about the Lisp editor that I would recommend, and that is the Notepad++. Now, you saw this slide before, and I showed you that you could basically create everything in Notepad. Very easy to do, but a product like Notepad++, which is a free editor, I would highly recommend it just because of the fact that it gives you just a couple additional tools and things that you just don't get if you're in Notepad. And so why don't we jump over there so I can show you some of the interesting things that you can do in Notepad++. Now, first of all, it does recognize LSP files as a certain type of file, so it does have some natural color coding. Now, I did change those. If you look under your settings and your style configurator, you can control the different types of colors that you have for different things inside of Lisp code. Also in here, you can create your own, and I do this where if I create my own function words, I can define them within the system and they'll show up. In my case, I like them to be magenta so I know that um, those are my particular commands. The other thing here is if I highlight a variable inside of the program, you'll notice that it highlights all the other locations where that variable exists. So that's a real interesting thing. And then also probably the most useful is if I highlight a open parenthesis, it'll show me where the other parenthesis that closes that code is. Probably, and you can, if you start looking at some of this code here, you can kind of tell that sometimes one of the biggest mistakes I make is just missing a parenthesis or putting one too many in. And so having the ability to scroll down and pick a parenthesis and see where that is, you notice this little green line here shows me where it also starts and ends. Just having that ability to have that is very cool. Also, I can minimize these anytime I have the open and close parenthesis. I can minimize those things, so I can minimize my functions and do that type of collapsing when I've got code that's getting to be real long. Or I can also split the screen. Now you probably can't see it because I got the video up here, but if I scroll this down for you, you can see here's my function for my make layers, and here I can reference what I'm doing over here. Just two files that are open. Nice to be able to copy paste check, validate things within the code. So highly recommend this if you haven't used an editor before. It's a free editor and it works really well. Now, the last thing I want to cover is going over some advanced examples of Lisp programs just to sort of give you an idea of what's possible if you haven't done it in the past or if you started doing some Lisp programs, just some of the things that you can do with Lisp. I think it's very intriguing and when you start thinking about some of the opportunities that you have within DraftSight because you have the ability to write Lisp routines. The first area that we see opportunity is in drawing processing or automation. What I mean by that is, let's say you want to create a whole series of drawings based on either a database, a spreadsheet, or you want to go through a series of drawings and extract that information out of them to create a spreadsheet. These are things that you can easily do with Lisp code. Also, we see opportunities when it comes to project migration. Give you an example, perhaps I've had companies that have purchased or acquired other companies and they have to migrate their projects from one server to another, and perhaps maybe all of the paths have to be changed because they were hard-coded before. And in order to migrate those, you'd have to open up every single drawing and remap those new paths for the new server so that things work. I had a company that had 30,000 drawings that they needed to migrate, and they calculated that it was going to take 3.5 years for an individual to go into each one of those drawings in the current projects, update them, and then be able to migrate to the current and proper path settings. So we wrote a program that was able to do that in a matter of a couple days to go through every one of those 30,000 drawings, take an existing pathing structure for their references, and then remap everything so that it would work on their new server. Other things that we see a lot of is plotting automation. Probably more so in the case where we want to generate either, it used to be sending a bunch of files to the plotter and making sure those are all configured properly. But today, oftentimes we see just generating PDF files or generating visual views or taking those layouts and automating that. In fact, I'll talk about that a little bit here. The other thing we can do with Lisp is we can have the program write a script and then run and execute that script. Now, in the session 6, I'm going to show you exactly how to do that, because this is the methodology. When I talked about that data migration for that company, that's exactly how we did it. We had a Lisp routine write a script routine that ran a Lisp routine, and it was sort of a cycle that happened, but I can show you how to do that process, and it might be able to allow you to do the type of automation, especially in those situations where you have to update or change hundreds or thousands of drawings. Now, in DraftSight and the other CAD programs, we have what's called multi-drawing mode or single drawing mode. And in a single drawing mode, we can open only one file at a time, but sometimes that is the methodology that we use to open a drawing, save it, close it, go to the next one, so that I'm not opening 1,000 drawings all at the same time within a scripted process. So there's things we can do in Lisp when we turn on single drawing mode and we run through a series of events. Now, the other thing we can do is we can redefine commands. In fact, different than aliases, we can actually take a command and redefine it so it does something different. So as an example, in session 7, what I do is I redefine the save command. So every time you pick save in your drawing, a prompt comes up and it says, do you want me to update all the tabs, all your layout tabs, and create PDFs of all those? And usually takes a couple seconds and it's done. So you can hit no or yes, but I have a dialogue and interface for that, and I show you how to make that whole process work. So in session 7, the last session, we go through a series of how do you set that up, how do you make it work, and how do you redefine the command, which is save. And then, of course, we do have the ability to create custom tools, custom interfaces, and things that we can do for building our own applications. And so I want to show this as an example because this is a block management tool that I put together, but I want to show it running in DraftSight, and I want to talk about it a little bit because of the fact that when I compare it to other programming languages, it's just a good example of why I really like using Lisp versus something like a .NET or a C++ or C#. So let me jump over to DraftSight and show you an example of this tool. Now here in DraftSight, what I've done is I've actually created a shortcut in my toolbar to launch this block manager tool that I developed. Now, what's different between this and, if you see on the right side, we still have the Design Resource Center. The Design Resource Center, again, like I explained earlier, allows me to drag and drop, which is very cool, and it's organized in a way that I can pick on my folders and drag those things in. But I cannot control the layer, or I cannot control how things are rotated. So in this program, I have an interface, and it shows me all of the drawings. And in fact, it tells me I have 49 blocks available in this folder, my furniture library. And I can pick on the different tabs to show the drawings or the blocks that are available in that drawing. Now, if you notice on the bottom, I have the ability to change whether I'm going to insert these blocks or edit the blocks. I can control this palette, or this, we'll call it a palette. I can control this palette so that when I place anything from this furniture library, that it goes on a specific layer. And I can specify whether I want to be able to rotate that or not. In fact, if I look at one of my other libraries, like my people library, well, I don't want to rotate these. I'm just going to drop them in. So I'll turn the rotate feature off. So, and if I grab any of these blocks, I'll actually put it on the people layer. So I'll give you an example. If I just grab this guy and drop him in, comes back, and you'll notice it's one pick and I'm done. I don't have to pick the X and Y scale factor. I don't have to pick the rotation because I don't need it. And these blocks are automatically placed on that layer. If I go back to my furniture layer and I grab let's just grab a conference table and I put it here, now I have the ability to rotate it, but notice I didn't have to type X and Y. And again, it's putting it, if you see up here, it's actually putting it on the furniture layer. So definitely an interface that makes it easy for me to drag and drop and place things in the drawing in a very dynamic way. Now, the other thing is I have this organizer button down here that allows me to see my libraries, copy files back and forth, move them, and select the blocks that are in the drawing, take a look at them. I can insert them, I can edit them. Just an interface to do all this. Now, the reason I bring this up is if you saw earlier when I showed you the example of that copy rotate function that we did in Lisp and what it would take to do that in .NET. A .NET program to do just a simple copy rotate function is about 200 lines of code. And I showed you how we could do it with a one-line Lisp routine or, one-line macro, menu macro. Now, this program that you're looking at here, if we look at all the definitions for how to create the interface, how to create all the behaviors, the multiple interfaces, and all of this entire program, everything all done is less than 2,000 lines of code. When you consider what you can do with 2,000 lines of code compared to something like a .NET or something else, it's pretty drastic in terms of just lightweight and capabilities. The other thing is I don't have to load up any libraries, DLLs, or any other things. This is a complete standalone program. Everything needed to make this whole thing work in less than 2,000 lines. So just an example that I wanted to show of something you can do with Lisp that is very powerful, and from a user perspective, very easy. But it took a little bit to do this, of course. But the fact is, I'm not. This isn't a program that takes tens of thousands of lines of code or has a bunch of libraries that are required to make it work. So I hope you find that interesting. So getting back to what we covered, we went over some system variables, some shortcuts. We talked a little bit about the CUI. We did some deep dives into dynamic blocks and some of the quirky things that can happen there. I talked about a couple golden rules. We talked about Lisp and Lisp editor. And finally, I talked about some examples. So if you are going through this training session, session 3, the next session, is really training to get you started into Lisp and into Lisp programming. Hopefully, I've kind of teased you a little bit about what you can do with Lisp, and so that I think you find it interesting to go down this path. And also know that the capabilities in DraftSight to do all the Lisp coding is very, very powerful. So keep that in mind, that you actually have the ability to automate so many things within DraftSight just because you have that ability to write Lisp programs. And by the way, that block manager that I showed you runs in multiple different CAD programs without any modification to make it work in both DraftSight and other CAD applications. So something also to keep in mind. Well, I hope you enjoyed this session. I look forward to having you attend those other sessions. And please, if you can, be active on the forums. If you have questions about Lisp in DraftSight or other customizations, there's plenty of folks up there that can help you or point you in the right direction. So hopefully you enjoyed the session, and I look forward to seeing you again. Thanks.